using expressions to read and write message data. As you saw at the end of the last example, there's a powerful expression language allowing us to access different items on our message. We can use this thing called the MMUULLEE expression language, or MEL. MEL allows us to access and evaluate the data in the payload, properties, and variables of a MMUULLEE message. MEL is lightweight and a MMUULLEE-specific expression language. MEL is usable in almost every message processor in MMUULLEE. It's used to modify the way processors act upon the message, such as routing and filtering. It'll make use of MMUULLEE-specific context objects. It is a case-sensitive expression language, and it is easy to use with autocomplete throughout your applications. Let's look at the basic syntax. You've seen these expressions around Studio already, but every MMUULLEE expression will be wrapped with a hash and square brackets. Inside of that hash and square brackets will be a context object, as we saw starting with the context of message. At the context object, we can then use dot notation to access fields or methods. So if we want to access the payload field on the message, we can put message.payload. There are some context objects, although less used than the message context, that we should call out. One of these is the server context. This will give you information about the operating system that the message processor is running on. The MMUULLEE context, information about the MMUULLEE instance that the application is running. The application context, that will give you information about the application the current flow is deployed in. And finally, the message, which will give us the MMUULLEE message that the processor is currently working on. So what does it look like to access areas of the MMUULLEE message? Well, say in the inbound properties on the left, we wanted to get the host. We could simply ask for the context message, the inbound properties field, and then the host field inside of that. Secondarily, if we wanted to get the method out, a slightly different syntax would be message.inboundProperties, and we can use bracket notation instead to access http.method. Often in MMUULLEE apps, you'll find the bracket notation is preferred when doing map access, and the dot notation is preferred when using getters and setters, although there are times where they can be used interchangeably. At the bottom, message.outboundProperties bracket notation content type shows a very similar request, but that's pulling data out of the outbound property scope rather than the inbound. Getting information out of the payload is very similar. We can use dot notation, or since this is a map, we could use the preferred bracket notation for map access. In the middle, we can see message.payload items total, calling the items total field and getting data. And we can also see, as the fourth example down, message.payload.toString. Since toString is a method available to whatever class the payload is, we can call that using MMUULLEE expression language. You'll also see in some MMUULLEE applications that developers omit the message when accessing the payload. If you see payload.id, you can assume that that's functionally equivalent to message.payload.id. Accessing relational map data. Accessing relational map data is often used when we need to access database results and similar data structures that have a key value pairing along with a list in them. So if we got a list of database results with people's information and where they live, we might want to access, in this case, Daler, which is in that second row and in the last name column. So we can call message.payload. We can ask for row index 1, which would be row 2, and column name last name and pull Daler out. Similar for Boston, we could ask for index 0 of payload, which would be row 1, and then the city field, which would provide us Boston. MEL also supports operators, similar to what you'd expect in most expression languages. You have your basic arithmetic operators. You have simple evaluation operators that you're once again used to. You also have some extra ones on the end, like contains, doing sort of a fuzzy like search, is being similar to instance of, where you check the type. One really helpful item in MEL is you have something for testing emptiness. So as you might know, a lot of times you'll get fields that'll be a blank string, 0, an empty collection, maybe null. Well, you can use the literal empty when testing against empty values. So think message.payload == empty would cover all of those different types of empty conditions. You can also do data extraction, including XPath with this XPath expression and regex using the regex expression. So let's see if we can use some MEL expressions inside of our own application. In walk through 5.3, read and write messages properties using MEL expressions, we'll use an expression to set the payload, an expression to display specific info in the console. we'll use an expression to set an outbound property, and finally use an expression to read an outbound property. Let's get started. Back in Anypoint Studio, let's select our setPayload processor. Now inside of our setPayload processor, there isn't an expression in place. There's just hello world. So let's turn hello world into an expression. To do this, we can wrap hello world in single quotes, and then put the expression notation around it, so the hash and the square brackets. Now we've got an expression in place, so let's see if we can do something with this expression. With the string inside, let's put a dot in, and let's set it to uppercase by typing in TO and choosing to uppercase inside of the method selection box. Now we've got hello world dot to uppercase operating on our string. Let's see what this impacts. We'll click and save the application, run the project, this time not in debug mode, just in normal mode. And once the project starts up, let's head over to Postman to make a request and see if it affected our payload. Inside of here, we'll hit send. And in the body of the response, we can see that we now have a capitalized hello world. So this is our expression evaluating at runtime and then providing a response back to our client. Let's see if we can take this a step further. Back inside of Anypoint Studio, if we select our logger, instead of logging the entire message, let's see if we could just log a list of query parameters. Well, as you might recall from our slides, we can get these by opening up a bracket. And in this case, I'll use autocomplete to get there. We'll start with message as the main context, put in a dot, and since this is coming in with the inbound request, the query parameter should be part of the inbound properties. With inbound properties set, I'll do another dot notation. And again, I told you I wanted query parameters, so the http.query.parameters field is what I want. Select that. And then at the end of query parameters, we'll just keep it as is for now to print out the full list of query parameters. So let's see what happens. We can click in our canvas and save our application. If we go back to our console, we should see that that save, as long as the app was still running, should redeploy the application. And upon a successful redeploy, let's head back to Postman and let's make the same request again. So we'll hit send. Go back into Anypoint Studio, and now inside of our console, if we scroll to the right, we can see the parameter map for our query parameters is now being printed out. So let's make one more change here. We'll make sure that the logger doesn't just print the whole list of query parameters, but instead prints the name query parameter. So we'll double click on the logger, we'll put in dot again, and then this time put in name, asking for the name query parameter. Once again, let's save this up. Wait for our console to show that it is redeployed. And once it's redeployed, send one more request through Postman. So hitting send in Postman this time should of course reveal in the console that we are logging just the name of that query parameter. Okay, so now we've seen an expression in the setPayload context, we've seen an expression in the logger context. Let's see if we can put an expression in our property as well. So let's say hypothetically that we want a response header to come back to the client, and that response header should contain the query parameter name that we're setting in our inbound request. Well, in this case, we'll keep the name as QP name, but the value needs to be dynamic based on the query parameter name that comes in. So once again, let's use hash. We'll use our message context. Again, this is a query parameter on the inbound property scope. We'll do dot again, asking for the HTTP query params. And at the end of HTTP query params, just like our logger, we can go ahead and set dot name. Now that we're capturing this query param and putting it in a header or an outbound property that will become a header on the response, I'd kind of like our logger to log the actual outbound property. That way we can be sure in the logs that it was captured. So let's go to our logger on the right, and inside of the logger, let's change this just a bit. Now that it's coming from set property, we know that it's going to be an outbound property because those are the only properties that we are able to set. So let's put in outbound properties. We know it's no longer part of the HTTP query parameters because we're explicitly setting it on the outbound properties. And the name of that property was QP name. So let's put in QP in front of name. It should read message.outboundproperties.qp name. Let's test this out and see what happens. If we click in our canvas and save the app, going back to the console, we should see it restart. And once the application is restarted, we'll enter back to Postman and make the same request again. So in this case, we'll hit send. If I go to headers, you can see I've changed my name to Sally in this example. So my QP name is Sally. Yours might come back as Max. But again, you should be able to change this and see it dynamically. So if I go to Max and hit send, we can now see that the header QP name is being set based on what that query parameter inbound is because of our expression. And if we return to AnyPoint Studio in our logs, we're of course going to see the respective name get log for each time that the expression evaluates. Let's be sure to stop our project and continue on to the next section.